In section 1 of chapter 8, we're going to be reevaluating square root functions again, except this time we're going to break that second to last barrier between you and processes you do not know how to do yet, which is we are going to start square rooting negatives now. I told you in the past that we can. Now is when I'm going to reveal to you how. But before I do that, I want to do a brief little recap of some problems that you've already done before in the previous chapter, because I'm going to tie this into what we're doing in this chapter. So, problem number 1, I have the square root of 9. The square root of 9 is just 3, because 3 times 3 is 9. The square root of 3x to the 5th. Well, I can't square root the 3, so the 3 is going to stay underneath the square root. But when it comes to the variable x to the 5th, remember this is a second root. So I ask myself, how many groups of 2 can I pull out of x to the 5th? You pull out 2 groups of 2. So we're going to factor out an x squared, and that'll be 3x that remains inside of the radical. And then problem number 3, I have 2 times the square root of 50x to the 6th. I could rewrite that as 2 times the square root of 25 times 2 times x to the 6th. I can square root the 25. I can square root the x to the 6th. So those terms can come out. 2 times 5x to the 3rd times the square root of 2, which simplifies into 10x cubed root 2. And then lastly, problem number 3, we're finally dealing with addition and subtraction of terms that have radicals. We learned that you can only add and subtract terms with radicals if they are the same radical. This is a square root of 7x. This is not a square root of 7x. However, this radical can be simplified. So this is going to be equal to 3 root 7x minus 6 times the square root of 4 times 7x. And I can square root the 4. The square root of 4 is equal to 2. So it's minus 6 times 2 root 7x, which is then equal to 3 root 7x minus 12. I don't like that minus sign. Minus 12 root 7x. And now that they have the same type of root, you can kind of treat it like a variable. You can kind of think of this as like 3a minus 12a. 3 minus 12 is negative 9, and then root 7x. This is a quick recap of the concepts that we went over in the previous chapter. What we're going to be doing today is just an extension of this. We're just going to incorporate complex values. Here is the complex number. It's also sometimes referred to as the imaginary number, although personally as a mathematician, I hate that notation. It is everywhere in mathematics, but I hate it because when I say the word imaginary number, a lot of high schoolers tend to think it's something that doesn't exist. I will tell you in this chapter, the vocabulary that we use is horrible. They chose the wrong words. These values, they do exist. It's just complicated. The square root of negative 1 is the most basic, fundamental, complex number, and we have a symbol for it. That symbol is I. Oops, wrong color. This is what we're going to be using to represent the complex number. I want to go over some brief examples as to how this is actually really easy to incorporate into the material you've already been utilizing. So I have some examples. We all know what the square root of 4 is. But the square root of negative 4, you can imagine that as just being the square root of 4 times negative 1, which is equal to the square root of 4 is 2, the square root of negative 1 is I. So this is just 2i. All the negative component does is just make you tack an I on at the end of your answer. The square root of negative 36, that's just the square root of 36 times negative 1. The square root of 36 is 6. The square root of negative 1 is I. That's your answer. Then inevitably we'll get to problems like number 3, the square root of negative 7. You might go, we can't square root 7. And you are correct, because this is the square root of 7 times negative 1. But you can square root negative 1 now. That's I. So the answer to this is I root 7. Whenever you see a negative underneath a square root, you can just pull it out as I. I'm going to go through the exact same 4 initial problems that we did earlier, except now I'm just throwing a negative in there. The negative doesn't change anything. The square root of 9 and the square root of negative 9 are going to have very similar answers. It's going to be 3, and for the negative component, it's just 3i. If you have a square root of 3x to the 5th and a square root of negative 3x to the 5th, all the negative is going to do is have the same answer. You're just going to throw an I in there. But here's the little kicker. When writing terms, we always write the number, then the variable. We always go 5x, 2x, negative 3x. We never go x5. We always put the number in the front. The complex number I is a number. So when I write this, I'm going to write the numbers first, then the variables. When you start getting to more complicated answers, like problem number 3 in green, where there's a number that's an integer and a variable, when you start throwing negatives into the radical, you're still going to have an I, but now it's going to go the knowable number, then the complex number, then we put our variable. And now that we're doing addition, subtraction, it's the same process. You can only combine terms together if they also have an I. So if a term has an I in it, it can only combine together with another term that has an I in it. Now we'll discuss this later on in the next section, but I will forewarn you, I is never ever allowed to have an exponent. I will only ever be brought to the first power. I will explain that more thoroughly in the subsequent lesson.